Warning, emergency alert. In the next 10 minutes, you'll learn what 99% of people don't. Keep watching. People are running from a collapsed building after a sudden tremor. Smoke and dust fill the sky, making it hard to see and breathe. A small group of people is trapped inside, their calls for help muffled by the debris. The situation looks dire. Human rescuers cannot safely enter the unstable structure. Then, a new kind of help arrives. Hundreds of tiny robots, no bigger than your hand, pour into the scene. They flow like water, moving over rubble and through small cracks in the walls. They are a swarm, and they are here to save the day. These small machines do not wait for orders from one central commander. There is no single person with a joystick telling each one what to do. Instead, each tiny robot acts on its own, following a very simple set of rules. It checks the space directly in front of it. It shares simple signals with its neighbors, like a firefly flashing its light. Working together, this collective of simple machines quickly maps the dangerous interior of the ruined building. One robot finds a trapped person and sends out a signal. The signal ripples through the swarm, and soon, they all know where to focus their efforts. The robots converge on a blocked emergency exit. Some clear away small pieces of debris. Others form a chain to guide rescuers. A few find a small, high window that is still intact. They climb the wall and work together to push it open, creating a vital escape route for the trapped survivors. Fresh air flows in, and hope is restored. The people inside can now see a way out. They follow the path cleared by the swarm. The tiny robots have done their job. They have shown how many small helpers, working as a team, can achieve what one large machine could not. This dramatic scene is not from a science fiction movie. It is a real possibility that researchers are working on today, and it shows the incredible potential of robotic swarms. The core idea is simple. Many small, simple robots can accomplish complex tasks when they work together. They do not need a single, powerful brain to guide them. Their intelligence comes from the group itself. This is a fundamental shift in how we think about robotics. It is not about building one perfect, all-knowing machine. It is about unleashing the power of collaboration on a massive scale. So, what exactly is a robotic swarm? Imagine a flock of birds, or a school of fish. There is no single leader telling every bird where to fly or every fish where to swim. Instead, each animal follows simple rules. Stay close to your neighbors, avoid bumping into things. When hundreds or thousands follow these rules at once, a beautiful, intelligent pattern emerges. The whole group moves as one, turning and flowing with incredible grace. This is the essence of a swarm, complex collective behavior from simple individual actions. A robotic swarm applies this idea to machines. It is a large group of relatively simple, often inexpensive robots. They work together as a single coordinated system. The key ingredient is decentralized intelligence. Decentralized means no single point of control. No central computer, no human operator making all the decisions. Each robot has its own small processor and its own sensors. It makes choices based on what it sees and what its immediate neighbors are doing, not like a factory arm on a pre-programmed path. That lack of a central leader is the swarm's greatest strength. It makes the group resilient and robust. Think of a traditional system with a single leader. If that leader is damaged or its communication is cut off, the entire system fails. All other robots would stop because they have no instructions. In a swarm, losing one or even dozens does not stop the mission. The remaining robots adapt and continue. The group can heal itself, reorganize, and keep moving, much like an ant colony. Communication is very basic. They do not have long conversations. They share simple information locally. A robot might signal, "I have found something interesting here," or, This area is blocked. Only closest neighbors pick up the message. Those neighbors pass it on, and so on. Important information spreads like a wave, letting the group coordinate across a large area without any single robot seeing the whole picture. The potential applications for swarm robotics are vast and transformative. One of the most promising areas is search and rescue. After a natural disaster like an earthquake or a hurricane, time is critical. Swarms of small, agile robots can be deployed immediately. They can crawl through the rubble of collapsed buildings. These are areas far too dangerous for human rescuers and for search dogs. Spreading out, they can cover a huge area very quickly. Using tiny cameras and sensors, they can build a real-time map of the disaster zone. They can identify pockets where survivors might be located and assess the structural integrity of the ruins. Another powerful example is agriculture. Imagine a swarm of small, wheeled robots moving through a vast field of crops. Each robot could perform a specific task. Some might analyze soil moisture and deliver water directly to plant roots, cutting waste. Others might use computer vision to identify a single weed and remove it without spraying the whole field. At harvest, the swarm could pick fruits and vegetables at peak ripeness, far more gently and efficiently than one large machine. A third example is maintenance and environmental cleanup. Our world has complex infrastructure like pipes, tunnels, and large industrial facilities. Inspecting and repairing these systems is often difficult, dangerous, and expensive. A swarm of tiny robots could be released into a city's water pipes. They would travel with the flow and inspect the pipes from the inside, finding tiny cracks or leaks early. After an oil spill at sea, aquatic robots could be deployed to find and neutralize the oil, working together to contain damage and protect marine life. In each example, the swarm does what a single robot or a human team cannot. Why are swarms so different from the single, highly complex robots we often see? Well, the answer lies in their fundamental design philosophy. A traditional robot, like a sophisticated humanoid or a large industrial rover, is built to be a jack of all trades. It has a powerful central computer, numerous complex sensors, and intricate mechanical parts. It is designed to be a standalone solution. While impressive, this complexity is also a weakness. These robots are incredibly expensive to build, difficult to repair. A single point of failure can render the entire multi-million-dollar machine useless. Swarms, on the other hand, embrace simplicity and redundancy. Each individual robot in the swarm is designed to be as simple and cheap as possible. It might only have a few basic sensors and one or two simple tools. Its brain is not very powerful. By itself, one of these robots is not very capable. But when you have 100 or 1,000 of them working together, their collective power is immense. This approach makes robotics more accessible and affordable. You can deploy a large swarm for a fraction of the cost of one advanced robot, making it feasible to use them for tasks where risk of loss is high. This distributed nature also makes swarms incredibly flexible and scalable. If you need to search a small building, you might deploy a swarm of 50 robots. If you need to search an entire city block, you can deploy a swarm of 5,000. The system scales easily to match the size of the problem. They can also change their formation on the fly. A swarm might spread out to cover a wide area, then quickly converge into a dense group to work on a specific task. This ability to dynamically adapt their collective shape and behavior is something a single rigid robot simply cannot do. It allows them to navigate complex and unpredictable environments with ease. Of course, this approach is not without its challenges. Coordinating the actions of hundreds or thousands of autonomous agents is a difficult problem. The simple rules each robot follows must be designed very carefully to ensure that the desired group behavior emerges and that the swarm does not fall into unproductive patterns, like all clustering in one corner or going around in circles. Communication can also be a challenge. In some environments, like underwater or inside thick concrete structures, wireless signals can be blocked, which could break the swarm into disconnected groups. Researchers are actively working on these problems, developing smarter algorithms and more robust communication methods. As we stand on the cusp of this robotic revolution, it is natural to feel a mix of excitement and caution. The potential for good is undeniable. Swarms could help us respond to disasters more effectively, grow food more sustainably, maintain our infrastructure more efficiently. They could explore distant planets, clean our oceans, assist with complex medical procedures inside the human body. The possibilities are truly as vast as our imagination. The image of a swarm saving the day is a powerful one. It represents a future where technology serves humanity in new and profound ways. However, there are risks and ethical questions we must address. We need to ensure these swarms are safe and reliable. What if a swarm's programming has a bug and behaves in an unexpected or harmful way? How do we prevent their malicious use? We must also consider privacy. Tiny flying robots with cameras could gather massive data. We need clear rules and regulations for how that data is collected, used, and protected, ensuring this technology respects individual rights. Building this future responsibly requires collaboration. Engineers must create robust safety protocols and transparent systems. Ethicists and policymakers need to work together to develop a legal framework that encourages innovation while protecting the public. Trust will not come from specs alone. It will come through demonstrated responsibility. Public engagement, a shared commitment to using these tools for the common good. The future of swarm robotics is not something to be feared. These robots are tools. Their impact depends on the hands that wield them. They represent a new way of solving problems based on cooperation, resilience, collective intelligence. By embracing curiosity and proceeding with cautious optimism, we can steer this technology toward its best potential. The day is coming when swarms of tiny helpers will be a common sight, working alongside us to build a safer, cleaner, more efficient world. The power of the many is ready to be unleashed.